Welcome to the third project of the SparkFun Inventor's Kit with MicroPython, Motion. As usual, we're going to start with a relatively simple circuit and work our way up. In circuit 3A, we're going to be exploring this component, a servo motor. Servo motors are a special type of motor that have three wires, one for power, one for ground, and one for signal. The signal that servo motors expect are voltage pulses, also known as a square wave. To create our pulses, we are again going to use, you guessed it, PWM. A key feature of pulse width modulation is the percentage of time the digital pin is on or off. This has a special term in electronics, the duty cycle. A PWM signal that is high a quarter of the time and low the rest of the time is known to have a 25% duty cycle. Similarly, a PWM signal that is on half the time is said to have a 50% duty cycle. For a servo, the duty cycle and corresponding pulse width of the PWM signal on its signal wire determine its angle of rotation, often from 0 to 180 degrees. So, if we have the signal of our PWM high for longer, aka a longer pulse width, the servo will rotate further. We need to keep delivering a PWM signal to the servo continuously to properly control and maintain its position. That's about it for theory for circuit 3A. Now let's build the thing. It's much easier to see the motion of a servo if it has one of these white things called a horn attached. So we'll do that now before we build our circuit. In this circuit, we will put our potentiometer back in the voltage divider configuration, where we use all three pins and read the analog voltage from the middle pin with A0. We connect the red wire of our servo to power, the black wire of our servo to ground, and the white wire of our servo to digital pin 28, where we'll be delivering our PWM control signal. Notice how for the Project 3 circuits, we are using 5 volts for the power rail, as components such as the servo motor and the distance sensor in the next circuit require that higher voltage for proper operation. As usual, this circuit consists of setup cells and an infinite loop that will actually run our circuit. In the infinite loop, we will read our potentiometer and then turn the servo based on its angle. I'm going to run this circuit with the Run All Cells and Advance button, and then we can see that as I turn the potentiometer, the servo will also move. Congratulations on completing Circuit 3A, our first lesson in motion. Next up is Circuit 3B, where we will investigate a digital distance sensor.